Okay, this project is about the simulation of a microwave oven. I'm going to demonstrate the input characteristic of our project using the keypad over here. A is used to set the time. B is used to set the cooking time. And C is used to set the power level. D is not assigned a particular function. E is used to pause, and F is to start the cooking time. Now, starting from the time, once I push on the A, it gives me the opportunity to enter the time. The first change I can make over here will be about the time by keying 0, 9, allow me to enter 9 for the time, and by entering 1 and 4 allow me to enter 14 minutes. The seconds, I don't have to worry about it. Now, next I'm going to push on the B, which allows me to enter the cooking time in minutes and seconds. Same scenario, 0, 1, allow me to enter 1 minute, and 55 will be 55 seconds. Now, for the power level, push on C, give me the option of selecting between from 0 to 9. 0 will be the default power level 10, and then 1 through 9, give me the option of selecting from 1 to 9. Over here, I'm going to select 5 over here. And you can see on the screen over here is display power 5. Next, if I want to start the cooking time, I just have to push on F, and the hum over here is the noise as food is cooking. Now, if I want to open the door, I just have to turn off the switch over here. It allows me to stop the hum over here. Now, next, if I want to start over, to continue cooking, I close the door and I go back over here, I push on F.
Our microwave oven simulator uses 2 clocks. We have a time clock on top and a cook timer on the bottom. They are both controlled using the RTI interrupt, set to 1 millisecond. So after 1,000 RTIs, the 1 seconds get incremented and decremented accordingly. So as the RTI is fired, the clock time goes up and the cook time goes down. And when the cook time is running, there's a flag set saying that it's only decremented when the cooking active flag is set. And when it's done, it sets a cooking done flag, and that triggers the speaker to do the food done alarm. I found the RTI timing was easy to set up, but difficult to get straight. The cook timer decrements until it hits 0 when we fire the food done signal.
Another integral part of this design is we actually, as we said, we have the power level going from 0 to 9, which is actually 1 to 10, because 0, the default, would be 10, and then obviously you have 1 through 9. So we use the LEDs to display to the user what power level that he's at right now. So right now all of them are on because we're at power level 10. So if I just go back to demonstrate and I press C for the power level, since there's only 8 LEDs but we have 10 possible power levels, 3 through 0 is actually going to be the first LED. There are usually lower powers that aren't used so much, so it doesn't cause too much of a problem. So here if I press, for example, 6, you see that the first LED will start at power 3 4, 5, 6, so 4 LEDs are lit. So that is just a simple statement stating that when a certain number is pressed, a certain number of LEDs are on. The next integral part of this design is the speaker. Now the speaker can be used using the output compare 5 and then writing the right information to the registers and the counters. What we did is we used it to create first of all a hum, which would simulate that the microwave is running and that time is cooking. The second thing that we use it for is when the cooking is done, to give us sort of a ring to basically simulate that the cooking is done. Okay, so how we're using it to set the hum is that we basically have it set at one frequency. We stay that frequency for 0.5 seconds, and those 0.5 seconds are set using the RTI clock, which keeps incrementing every milliseconds. So we have a certain delay, so we'll be at that frequency for 0.5 seconds, and then we'll delay for a certain amount of time, and then we'll go back for another 0.5 seconds, and that oscillation causes what you hear as a hum. Now for the done cooking, we just want a couple rings, so we actually use the same process, but we have a low frequency and a high frequency. So we're going to be on the low frequency for 0.5 seconds, and then we're going to actually, for 0.5 seconds, go to a higher frequency. And the oscillation between the two different frequencies will cause that little ringing noise that you hear when the cooking is done. Next is the IRQ interrupt. As we used in Lab 4, I believe the IRQ interrupt would be port E, pin 1, which is right here. And we just have the switch hooked up to one side to ground and then the other side to the IRQ interrupt. So whenever the IRQ interrupt is set to low, since it's active low, it causes the IRQ interrupt. Now we use that to simulate the door opening. So now in the code, it's set up so that when we set the IRQ interrupt or the door is open, it actually pauses the cooking clock, which it would if you open the door in any microwave that you use in your home. And then once the clock is set, once the door is closed or the switch is set, then and we press start as we demonstrated before, the cooking clock continues to decrement. So there you have it. That is how our microwave is simulated and how it works using the board.